In this video, we will take up probability by binomial distribution. While using binomial distribution, we have to keep certain conditions in mind. One, that the number of trials are fixed. Second, you have two outcomes, that is success and failure. The probability of success is fixed, and the trials are independent of each other. Look at this problem here, which states that the probability of student being left-handed is 0.475 in a class of 15 students, which gives us the number of trials, right? So the number of trials in this particular case is 15, n equals to 15. Now we have two possible outcomes of a student being left-handed or not left-handed, that is right-handed. We will consider it as either left-handed or not left-handed. So we have two possible outcomes, and the probability of success, which is identified as being left-handed. So the probability of success, a person being left-handed, is, we'll call it probability 0.475. Right, so in this particular case, X follows a binomial distribution with number of trials 15 and the probability of success being 0.475. So we identified that we have to use a binomial distribution in this case to find the probability. So what does the question ask us? Find the probability that there are exactly, so look at the word here, exactly 8. So when there is exactly 8, so we use binomial PDF. So remember, when there is an equal to sign, you use binom PDF. When there is a less than or equal to sign, you use binom CDF, right? So this is something that you need to keep in mind. I did not write greater than equal to because the GDC is not programmed to calculate for greater than. So any problem that deals with greater than, we have to convert them into less than or equal to. So now let's get started with solving this problem. Exactly 8. What does that mean? Exactly 8 means the probability of the number of students is equal to 8. So x is equal to 8. When it is x equal to 8, what we'll use is on the GDC. I'll go to the GDC, and then, so what we have here is we start with, I hope it was clear. Let me put this up a little bit down. So go now to binom PDF, right? Enter. Number of trials is 15. Probability of success is 0.475. The x value was 8. And calculate. Right, I've done this before, but anyways, so this is 0.183 because we are taking it only to 3 SF. So 0.183. As you can see, the answer is 0.183. Now, let's go to the next question. There are no left-handed students, which means 0 left-handed. That is probability of x equal to 0, equal to, again we are using equal to. That means we would do binom PDF. Since I already did this, it's the same process. Go ahead, number of trials is 15. The only thing you're going to change out here is the ones here, second verse, because it's distribution. And then rather than scrolling down, I'm going to scroll up here and then go up here and go binom PDF. Binom PDF, everything else is fixed. All I need to change in here is just a 0. So bring that to a 0 and then paste and then enter. And then enter, and that would give you, now look at this number here. There is a E here. Please don't copy this E in your answer sheet because it's not allowed to write it in this, but this is a calculator format. You're supposed to write it in either in the scientific form or as a decimal. So the E represents 10. So this basically means 6.344 times 10 to the power of negative 5. You may either write it in that format or you can convert it into decimal format. So that would give us 0.00000634, which is to 3 SF. Right, now look at the next question. There are more right-handed students than left-handed students. So the number of left-handed students is more than. Now remember, our calculator is only programmed to do less than. So what we are going to do is rephrase the question as the number of left-handed students. The number of left-handed, I'm just going to write this as left-handed LH, is less than, right? The number of left-handed students is less than the right-handed students. Okay, now there are 15 students in the classroom. So if there are 15 students in the classroom, so now if I were to do 50%, that means if there were to be equal number of left-handed and right-handed, I'm just doing it roughly here, 15 divided by 2, which would give me 7.5. Now obviously these are number of students, so you can't have 7.5 students. All right, so if I were to have 7 and 8, 7 plus 8 would give me 15, right? So in this particular case, 7 would be the number of left-handed students because left-handed are less than the right-handed, which would easily allow me to get the number 7 for the number of left-handed students, which is what I did here. Probability of X is less than or equal to 7. Because if we have 7 or less students, then it satisfies this condition. That means there would be 8 or more students who are right-handed. So now, because there is a less than equal to sign, we will use binom CDF, right? The process is exactly the same. We just go there, click on binom CDF instead of, so second parse, go to binom CDF. Everything else is the same, 15. Probability of success. Remember, we are doing left-handed, so we don't have to change the probability of success either. X value is 7, and then paste, and that gives us 0.578. That is to 3 SF, and that is exactly what you have here. Sometimes the probability would be given in percentage. Remember that you have to convert this. For example, this could have been given to you. The probability of a student being left-handed is 47.5%. Remember, in that case, you have to convert the percentage into decimals because of the way the calculator is programmed to solve these kind of questions. So all percentage questions, whether they are when the probability is given as a percentage, remember to convert them into decimals, right? Hope